Okay, so let me know if you have any confusion up to the last class. What about others? Teza, Emil, Miki?
No, sir.
Sir,
Yes.
the syllabus, sir, for the classes.
Hmm?
The syllabus, sir, for the classes.
Okay, syllabus for class
Yes,
test, that
sir.
will be the first module that we have discussed. Okay, and from this module you can expect one cam design problem. Okay.
That is displacement diagram, no, sir.
Yeah.
This displacement diagram problem, sir.
Not only displacement diagram, cam designing we are talking about. Okay, that means first step will be
Okay, sir.
displacement diagram, then we'll be designing the cam. Okay, so that kind
Okay,
of problem. Okay, and
okay,
from the first, so maybe from up to today's or tomorrow's class, that will be up to this one. Okay.
okay, sir. Okay, sir.
Okay. So yesterday what we were discussing, do you recall?
The numerical sir on the
One problem
diagram
we are
problem.
solving, right?
Yes, sir.
Okay. Okay. So so that problem we have half done. It was half done, right? Okay. So we'll just once again just go through it. Okay. We'll show the steps so that you can understand better. Okay. In the meantime, I request all of you to take out your page, pencil, and other geometrical instruments so that you can try drawing it alongside me. Okay. All of you be ready. Once you are ready, let me know. I'll start. Let me know once you are ready. We'll start. Okay, so I have all of you are ready. So okay,
Sir,
so I'm just yes.
sir, in this question, sir, this maximum radius of cam, this will be given, sir, in the question.
This is not maximum radius. This is the minimum radius of cam. Okay,
Yes,
that
sir,
means it
minimum
will be given
radius.
so that you can get the initial idea about the base circle of the cam.
Okay.
Okay, so that will be given. Okay,
Yes.
so now as per the question, you have to draw a cam profile. Okay, where the type of motion is uniform acceleration and deceleration during both the strokes. Okay, minimum radius of cam given 25 mm. Okay, so all those given that I will write down. Roller radius is given 7.5 millimeter. So from here we understand that right now this is a case with here the follower is roller type of follower. Okay, in the previous case it was knife edge follower. Then lift is given and the offset of the follower axis is given 12 mm towards right. So that means you understand that now it is not inline, it is offset type of cam and follower arrangement. And after that the ascent stroke angle, descent stroke angle, etc., those things are given, and speed of cam also is given. Okay, you have to draw the profile and find out some of the like maximum velocity, etc., okay, during both the stroke. So once you get this, first step is you'll be writing down all those given data and find out all those whatever angles that is not given. Generally the some second delta is generally not given, that can be obtained from if you know about the other three angles, that can be obtained from deducting it from 360 degree, that is the complete angle. Okay, so now the first step is, what are the two stages involved? First step is you have to draw the displacement diagram. Second step, by utilizing the data from the your displacement diagram, properly drawn displacement diagram, you need to draw the cam profile. Okay, so now while drawing the displacement diagram, what are the important thing? First thing is you need to know about the different angles. Okay, that is ascent stroke angle, descent stroke angle, etc. Okay, then the different angles are required, then the leaf value that is required. Okay, now next thing that is required is what type of motion that has been exhibited in a particular stroke. Okay, whether it's in the ascent stroke it is like what type of motion, and in the descent stroke what type of motion is there, those things you must know. Okay, so really after that, like if considering a proper scale is very very important. Okay, and after that, as per whatever scale that you consider, okay, so you have to draw the displacement diagram. Okay, so now here along the x-axis, what we consider while drawing the displacement diagram, we consider the what cam angular displacement, the theta. Okay, and along the y-axis, that is the what, lift. Okay, so that is the thing. Now here, as I have already discussed, scale is very very important. Okay, considering proper scale along x-axis as well as y-axis, that is very important, and you need to write it down. Okay, that means along x-axis, depending on whatever is the angles theta a, delta, theta d, etc., a judicial scale will be considering. Let's consider, suppose here, what are the angles? Theta a is, that is ascent stroke angle, 60 degree, descent stroke 45, like delta, that is the first delta, that is your first dwell, that is 45 degree. Then we have 90 degree as the descent stroke angle, and the second dwell is 165 degree. You may consider like along x-axis 15 degree to be 1 centimeter, like that. Okay, so 1 centimeter denotes 15 degree. So that is how, if you need to draw, suppose theta a, then 60 by 15, that is your 4 centimeter, like your for the first delta, that is 3 centimeter, like that you have to draw. Okay, but prior to that, you need to mention what is the scale that you have selected. Up to this much, I hope it's clear. Next thing is, like as it is being said that it is now, okay, so along x-axis we will draw the horizontal line, and we will be dividing it, the theta a, delta 1, del 1, theta d, etc., as per the required scale. And along y-axis, as per the scale that you have considered, the lift we have to consider. Then we will complete this particular rectangle. Okay, and after that, what we will do is ascent stroke and descent stroke will be dividing into some equal number of even number of parts. So now we are considering six division, okay, for ascent stroke as well as descent stroke. So whatever is the theta a, that is ascent stroke angle, that will mark like 1 2 3 4, like that. Okay, the division, and we'll draw the horizontal lines. Displacement of that particular follower in that particular case. Okay, so similarly, theta d also will be dividing into uh,
हेलो नमस्कार
सर को कोई पर्सनली मैसेज करो ना। सर को बोलो ना।
सर लेफ्ट हो गया ना
हाँ, छोड़ दिया वो, सर को बोलो।
Hello, Permiji.
Good morning, sir.
Good morning, everyone.
गुड मॉर्निंग सर नमस्कार मैसेज किया सर शायद मैसेज सेंड नहीं किया ना क्या हेल्पर
क्या भाई?
सर शायद मैसेज देखा नहीं ना क्या
सर को वो सर को कॉल करे क्या?
करे क्या
कर ले तो सीआर को बोलो, हमारा थोड़ी ना काम। सीआर को
यार नहीं
बोलो।
है
सीआर
बसुमतारी
भी
नहीं
नहीं
है
है, बसुमतारी भी नहीं है।
नहीं ज्वाइन
क्या
नहीं
करेगा?
किया
जॉइन नहीं है तो देखते हैं। कॉल करना भाई, तू ही कर।
कॉल करूँ क्या
हाँ हाँ,
कॉल करूँ क्या
पूछ ले क्लास होगा कि नहीं होगा, क्या वो बीच में छोड़ दिया। नहीं तो यशोदी सर को करते, फोन करते।
व्हाट शुड वी डू गाइस
Bro, start recording.
आई थिंक सो वी शुड कॉल सर।
व्हाट से अदर्स
अदर्स ओपिनियन। और मिगे, और मिगे का तो भोज नहीं आ रहा
Yes, bro.
है।
No,
यूएस,
I said
ओके,
start
भेजा
recording. Okay,
भेजा।
Yes, yes. Everything's
start
यस।
fine.
recording. Okay, bro. Okay, okay, everything's fine.
कौन कॉल करेगा? हु इज गोना कॉल?
Rehan,
रेहान भाई।
यस ब्रो
Text me
हाँ
you
call
close
यार.
there.
ठीक है मैं
चल,
करता हूँ हाँ
कर कर।
आई डिडंट रिसीव फोन
रिकॉर्डिंग में डाल दिया है किसी ने।
मैं कॉल किया सर रिसीव नहीं की
तब तो रिकॉर्डिंग में कैसे आ गया वो फटक से? सर तो मैं कर, थोड़ा देर रुक जा, रुक। थोड़ा देर रुकते हैं नहीं कि क्या कहते हो?
हाँ थोड़ा देर देखते हैं
देखते हैं।
अभी तो टाइम है ना
अब मैं एक बार ट्राई करता हूँ, रुक।
हाँ मैं शायद वो दूसरा नंबर से किया ना
Hello, am I audible? Hello.
Yes, sir.
Yes, sir.
So when did you lost me? I just got a call from Nilotpal.
Sir, I
Yes, sir.
also called, sir.
Okay. So actually, yes. In between, actually, I have been like I have been presenting and I have been discussing so many things. I didn't know that I got like some network issue was there. So up to how much you have? Up to how much you have covered?
So you were explaining the diagram, sir.
The presentation is not there, sir.
Yes, sir. Presentation is also not there.
Sir.
Hello.
Yes, sir.
Just wait. Okay. Some I think some problem is there with Google Classroom today or Google Meet today. In between, I'm presenting and once again it is showing present now. Just wait. How much? How much you could see?
So we cannot see the PPT, sir.
Sir, cannot
If
see.
Yes, sir. Yes, sir.
from the very beginning you
Yes,
couldn't
sir.
see the PPT.
No, sir. At the
Nothing is
first,
coming, sir.
it was visible, sir.
It was visible, but in between
Sir,
you lost, no?
yeah, in
Yeah,
between,
sir.
sir, you left, sir. After that, it's not visible.
Okay, in between I got disconnected, na? Okay.
Yes, sir.
Actually, I was just like with using that particular slide, PPT, I was just explaining and explaining. After that, I got the call only. Then only I got to know. Okay, so sorry, I don't know. Some I think network issue is there in the college. I am right now also I am getting disconnected. Once again, I think I got connected. So some problem is network issue might be there. Okay, so anyhow, the displacement diagram you have understood, no? So displacement diagram, I think there should not be any problem with the displacement diagram. Hello.
Yes, sir.
Okay. I'll just leave and I'll once again reconnect. Okay, you don't leave. Okay, I think now it should be okay. So can you see the PPT, this slides now? Okay, figures.
So yeah. So it's not visible.
Now it's visible, no?
Yes,
Okay.
sir.
Yes,
Okay.
Yes,
Okay.
sir.
Okay.
sir.
Okay. Okay. So up to how much you could like I think the displacement diagram you could see. Okay. So this diagram previous while I was explaining how to draw the cam profile, this cam profile drawing up to this much have you followed?
Sir, I think we were at the theta point, sir, by taking this values from 0 to 1, 1 to 2. And after that, you left, sir.
That means this displacement diagram is over, right?
Sir, for dual and descendant, sir, I think it was not done. We were
Okay.
not able to listen.
Okay. Yesterday also I have discussed. Okay. So don't worry. I'll just discuss. Okay. So
Okay.
for the dual, so now already your after the end of this particular whatever is this particular stroke, that is the descent ascent stroke. Okay. So it is here. Okay. Okay. So this is the dual. And after that, in the descent stroke, it is once again with the same type of motion, that is uniform acceleration and retardation. So in the same way as that of the you have drawn this particular curve for the ascent stroke, will be drawing in the same way. Okay, so this is the end of your uh, this particular step, first step. Okay, so the second step is drawing the actual this particular cam profile. Okay, so for that, now the assumption you have to consider, that is the assumption of kinematic inversion. So here we will consider that your cam is stationary and the follower is rotating around the cam in the opposite direction to that of the movement of your cam. Okay, so and the Now once again you will just consider the scale, whatever scale you consider, and you have to draw a circle with now radius equal to RC plus RR. That is the addition of the radius, the minimum radius of that particular cam plus the your roller radius, because we know that tracing point for a roller follower is at the center of the roller itself. Okay. So you do one thing, you in between you just respond, okay, whenever I have been asking questions or whether you have understood or not, you try to respond. Then only, because if you were responding, I would have known that means your some problem is there. And because you generally don't respond, that's why I just wait for some time and then I continue. Okay.
Okay, sir.
Okay.
Okay, sir.
Otherwise, I will not know. Na? If similar situation happens in sometimes, I will not be able to know. Okay. So now this is this particular circle. This is the circle considering r equal to RC plus R. Okay. Now after that we'll be drawing a concentric circle. This circle taking radius value equal to the offset value. Okay, and this is the circle that we have drawn. Okay, so now if this is the concentric circle, means it has got a radius equal to the whatever is the offset value that we have considered. Okay, that means if I draw tangent to this particular smaller circle, then each and every time this distance from the center will be how much, the offset value only, because radius is equal to offset. Okay, so now we'll consider the initial position of the roller follower to be vertical to this, and considering this particular line, this is this one. Okay, considering this, okay, this particular tangent, we are drawing the roller here. Okay, so roller we'll draw here taking whatever is the roller radius. Okay, after that, the center of the roller with the center of this particular circle will join, and we'll consider this as line as this particular baseline. Okay, and whatever this theta a, del 1, theta d, etc. was there, as per the given value, we'll just divide those angles here. Okay, so we'll be making the divisions for ascent stroke, dual, descent stroke, etc. here. Okay, so first angle is this 60° up to this much. Okay, next dual angle is 45°, this gives you 45°. Okay, next your stroke was descent stroke, that is 90°, so this is 90°, and automatically this portion becomes the next dual. Okay, so this is the about dividing this. Okay, so after that what we will do, after that, looking at that particular as your displacement diagram, the number of division, whatever the number of division you have made here, it is in the ascent stroke and descent stroke, similar number of division, okay, the marking wise will be making in this particular circle also. Okay, so now we had gone for 6 division, so here also 6 division will be making. Okay, so we'll just now this time we will not be drawing line joining those lines like this. Okay, but while dividing, but we'll just mark in the periphery. Okay, suppose 2, then 3, 4, 5, and 6. Okay, now the dual stroke we don't have to divide anything. Okay, similarly this angle, this 90° will be dividing once again in the 6 number of division, because we have made 6 division in the descent stroke. Okay, and we'll just mark them, this 7, this 8, okay, this is 9, okay, this is 10, 11, and 12, and so on. Okay, and then this is once again the which stroke, second dual, we don't have to make any marking. Okay, so now up to this much I hope it's clear. So we have given the name. Okay, 1, 2, 3, 4, all those division name, whatever naming you have utilized, nomenclature you have utilized in the displacement diagram, similar to this much. I hope that's okay. Let me know.
Yes, sir.
Okay, next step, what we are going to do, we are going to draw tangents from those division. Okay, this 1, 2, 3, 4, 5, 6. Okay, we are going to draw the tangents to this particular smaller circle, this offset circle. Okay, so what we will do, from those points, those 1, 2, 3, 4, like that. Okay, so we are going to draw those tangents. Tangent means what? A tangent in how many points it touches to that particular curve. Okay, we are drawing a tangent to that particular curve. This curve is circle. Okay, so it doesn't intersect. Okay, but it touches at a single point, right? So if it's the circle, so at a single point it touches, this is the tangent. So but this kind of thing, it is not tangent. Okay, this kind of line is not tangent. tangent that touches at a single point. Okay, so now to that particular smaller circle, from those division we are drawing tangents. Okay, 6 tangents. Next, for the from here to here, this is your from here to here, this is 12. You don't have to make any tangents and all. Okay, next, once again from this side, okay, for those division we have to draw tangent. Okay, so from here this is a tangent, 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 and this is the tangent. Once again, this is over. Okay, recent stroke we don't recent stroke is over. So for the next duel we don't have to make any tangent. Okay, now this time, once again, just like the previous case, we'll go and see it from the displacement diagram those value of displacement, that is 1 1 dash, 2 2 dash, 3 3 dash, 4 4 dash, 5 5 dash, and 6 6 dash. Similarly, for the descent stroke, this is 6 6 dash, then 7 7 dash. These values, these distances will measure using scale, and that much will be producing from those corresponding division along that tangent. Okay. Now this is, that's why those tangents are important, because this will indicate that throughout that particular, as this is the tangent, that means tangent means always tangent to this particular smaller circle, means always that position, if you consider, then at that particular position whenever the roller follower is there, it is always opposite to this particular circle. Okay, so now considering those 1 1 dash, 2 2 dash, those values from those displacement diagram, this much we are going to produce from those corresponding positions, from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, 6 to 6 dash, and so on. Similarly, for the dual stroke, we don't have to make anything. Once again, for the descent stroke, we'll start. Okay, so end of starting of the descent, 6 to 6 dash, this 7 to 7 dash, 8 to 8 dash, and up to like that. Okay, up to this much, is it clear?
Yes, sir.
Okay. Now this 1 dash, 2 dash, 3 dash, 4 dash, those extended points, whatever we have observed, those are nothing but the different position of the roller at different location. Okay, so these are the roller position that is. Now what last step is remaining? Last step is considering this 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, etc. as the center. Will be drawing the, taking those as the center, we'll just draw the ruler here. We'll show the ruler. So in that case, you can either draw the whole ruler, okay, that is whole circle, taking the ruler radius, okay, or you can show the lower portion, lower half of that particular ruler, because we are interested in where the contact is there of that particular ruler along with the cam surface, because we know the lower portion also only is in contact with the cam profile or the cam working surface. So now taking 1 dash, 2 dash, etc. Okay, so we'll be drawing the location of the roller. Okay, so similar, taking this 4 dash as the center, taking roller radius, this is the roller, 5 dash is the center, this is the roller. Okay, 6 dash, this is the roller, and so on. Okay, similarly, once again for the descent stroke, taking 6 dash as the circle. Okay, this is the roller, this is the roller. Okay, similarly this is the roller and on. Okay, so that's, you can see in this particular figure we have shown only the inner lower portion of that particular circle only, because that is what is our interest. You can either show the whole circle also for the roller. Okay, that is up to you. Okay, so now we know the location of the roller, and this roller is in, we know as contact with, constant contact with the cam surface. Yes, so now if we just join those endpoint, lower points of those particular roller position with a smooth curve, okay, then that gives you the indication about the, because that is in roller, that roller follower, the roller of the roller follower is in constant contact with the cam working surface, so that will be in contact with the follower. Okay, so now starting from the first roller position, this roller will just join with a smooth curve. Okay, so done. Now from here to here, this is the dual. So dual means constant radius. So whatever is this radius, so constant radius curve you will draw up to this much. Then next, once again, the lower position of those rollers. Okay, this way you will just join with a, okay, smooth curve up to this much. Done. Okay, and after that, once again, this is the your dual only. So constant radius curve. Okay, whatever is this. Okay, So this is what is your required cam profile. Understood? This is the cam. Yes. Done. Understood?
Yes, sir.
Okay, so this is how you have to draw the cam profile for offset type of cam. Okay, so if it is type of if this is type, we can say like had it been a knife edge follower, then we'll be considering the circle radius to be only RC only, and exactly there itself the trace point will be there. Okay, rest will be similar. And after that, just by using the known relationship, okay, we are going to find out the uniform acceleration, maximum velocity, etc. Okay, so and you have to be sure that means while for ascent stroke, the ascent stroke angle only you have to consider, for descent stroke angle you have to consider, and those angle has to be in terms of radians, not in degree. In degree it is given, just okay. So using the known relationship, just
Sir,
Fine.
छोड़ दिया ना उसने नहीं
यहाँ तो प्रेजेंट है सर,
प्रेजेंट है चला गया
प्रेजेंटेशन भी है
ये
okay. So
प्रेजेंटेशन
yes,
सर.
yes, I know. It's once again some. Okay, some network fluctuation was there. Okay, so we'll be giving the attendance to you people today. Okay, so I think you have understood the thing. Let me know, and I will stop here.
यस सर
Okay,
Yes, sir.
so okay, sorry for the network fluctuation. We'll stop here. If you have any question, you can ask. In the meantime,
सर
I
we'll
don't
go through
know.
that sir we'll go through that I mean topic and I will come back to you sir I have to go
Okay,
through
okay,
it.
okay. That will be great. That will
Yes,
be great. Okay, so we'll stop here. I'm giving the attendance to everyone.
okay. Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you sir
Thank you, sir.